I am very excited today to talk to you about the future of artificial intelligence. But to do that, we have to acknowledge the fact that it's actually constantly evolving and changing. And it's not just because time changes, right, and the future keeps moving ahead, but it's also because our definition of what artificial intelligence is keeps changing. It started when, early days, we thought if we could play chess really well, like some of the really smart people in the world, they're really good at chess. If we could do that, then we cracked intelligence. And then we'd have this really smart AI that could do all these other things. And that didn't really quite happen. In fact, there's so much hype and excitement around AI, and then some things didn't quite work out as well. So here is something from just 2006, it was exactly 10 years ago, a demo on speech recognition where people thought, we cracked speech recognition, we're going to solve all these other problems in artificial intelligence too. And so let me show you an example here of what AI looked like 10 years ago.
Dear Mom, comma.
Dear Mom went to Dear
Fix
Aunt.
Aunt. Delete that. Delete that.
There's a live product
Delete
demo.
that. Select all. I think it's picking up a little bit of echo here. Delete. Select all.
So 10 years ago, that's where we were in AI. And just a couple months ago, you may have heard about Go. And we can now play the ancient game of Go, which is amazing, right? There are so many possible combinations that would be impossible for any computer ever to go through all the possible combinations of a game of Go. In fact, if you try to type in this kind of large number on any calculator or any computer, it would just say infinity in most cases. I tried it just before this talk on Google. So at the same time, it's amazing that we can play Go. And the way the field has solved this is by using not just traditional machine learning, but also deep learning techniques, so-called neural networks, which can deal with much larger data and are very efficient on newest kinds of gaming platforms like GPUs, graphical processing units. Now, some things have changed in the last 10 years. We are now actually able to do amazingly good speech recognition, right? A lot of people start using Siri, and it's actually working. And so what's changed? Like, we can really now not just do speech recognition, which in some ways is kind of simple, but we can also ask relatively short questions and get answers. And so to give you a sense of what's possible, I'll show you a demo now of something that we've built. And what's amazing about this is that we're actually able to use the same kind of architecture for asking a lot of different kinds of questions. And in the last couple of decades, all these different kinds of questions would have required hundreds of PhD students working for several years to solve one particular problem. And now we can have one architecture, one artificial intelligence type of algorithm that can answer all these different kinds of questions. So here's an interesting sentence that is the kind of sentence that most AI systems, even up until maybe 4 years ago, would have totally gotten wrong. The sentence is, the best way to hope for any chance of enjoying this film is by lowering your expectations. So it has all these positive words in there, right? Best and hope and chance and enjoying, yet it's actually negative. And algorithms now can actually understand this and correctly identify this sentence as negative when you ask, what is the sentiment of this sentence? What's even more amazing is these algorithms work for any kind of language. Nowadays, you don't have to be a domain expert in a specific language like Chinese to train a Chinese language or sentiment algorithm. You can actually just give it a lot of sequences of characters, and just like English characters or English words, it can learn from all this data. So I'm not going to make a fool of myself trying to read that sentence, but it's kind of a funny sentence as well. Now, you can ask all kinds of different questions, and in fact, to the algorithms, it's the same thing if you ask a question about language as it is when you ask a question about images. So we can also ask what are the men wearing on their heads, and the answer is helmets. And we can ask, why are the men wearing helmets? And the answer is safety. There we go. So to the algorithm, and this general purpose algorithm, you give it any kind of sequence. This could be a sequence of pixels, a sequence of Chinese characters, a sequence of English words, and you give it the kinds of questions and answers that you want it to learn, and it will pick that up. So this is kind of a nice improvement over a lot of the AI algorithms in the past. And so as this definition of AI constantly evolves, we have to really think and ask ourselves, what is not just artificial intelligence, but what's human intelligence? What are we trying to run towards? And a lot of times in the past, people thought of the smartest people, and they're like, well, the smartest people are really good at math, so maybe that's what we should tackle. But of course, computers are better at math, most kinds of math, than humans already are. Same with chess, and then same with memorization, right? We think a lot, very highly of people who can memorize a lot of different facts, but computers are already better at all of these things. So that clearly isn't what we think of ourselves as defining our human intelligence. And so there are actually a couple of interesting places where AI still struggles, and that's where we'll see also AI evolving in the future, and that is things like motor intelligence. We don't consider golfers the most intelligent. It's a very monetizable skill. We pay people a lot of money if they can throw a tiny ball into a small hole somewhere far away. But we don't consider that intelligent, but that is actually a large part of our brain. It's using our brain to do complex motor interactions. And we still don't have robots that are good enough and versatile enough with all the actuators and everything, and different joints and all the degrees of freedom that we have to train that as efficiently as humans. There are other kinds of problems, not just like creativity types of issues that we can't solve yet. Really, computers are only good when we teach them a specific skill. If we want them to move outside of the skill, they usually still fail. And they also still struggle with some ambiguity. So here's a very fun example from just a couple of years ago, which I think is maybe still true, and that is whenever Anne Hathaway stars in a movie, and the reviews for that movie come out and they're really positive, the stocks for the company Berkshire Hathaway go up a significant amount. So that tells you that people are already trying to use artificial intelligence algorithms to automatically trade and do algorithmic trading, and they're still struggling with ambiguity. They're still mixing up Anne Hathaway and Berkshire Hathaway, and somehow they're doing that over several movie iterations. So as AI evolves, I think we will learn more and more about what makes us unique. And in some ways, I think we'll eventually merge, and we'll see certain things that we thought as very basic to the necessities that we had as people, and we'll see them actually get automated. I think in the future, and this is kind of, there's a big if in here, and that is if the political systems are designed such that everybody can actually benefit from these advances of artificial intelligence. It's a big if. We can talk a lot about that. I'm not sure we're always going in the right direction right now about this, but if the system is set up such a way that everybody could benefit, there is actually in the future, I don't think, a necessity to work for some of the most basic requirements that we have with food and shelter. You already have AI algorithms from a fun company called Blue River that automatically picks lettuce leaves, and it already automatically thins out lettuce leaves and can drive big tractors over a field. And about 150 years ago, the estimates are over 90% of people worked in agriculture, worked in the fields. Now, that's changed a lot, and I don't think 90% of this room are bummed out about not having to work in the fields every day. But it's a constantly evolving process, and I think we can use AI for a lot of the kinds of things that we consider sort of grunt work that is not that fun. So I think we'll see a lot of interesting places where our intelligence will merge with artificial intelligence. We already a lot of people use their phones as sort of their extension. A skill called navigation skill, I'm pretty worried about a lot of people in the younger generation these days who just grow up with GPS to read maps and navigate. And it's not an intelligent skill that you just need anymore because your phone will do it for you. And so I think in one of the most exciting areas of the merging of artificial intelligence, human intelligence is in medicine too. Very few people in the world have access to the kind of medical support and systems that we have, especially here with UCSF and other hospitals in the Bay Area. And in, for instance, radiology, we will see that radiology is really great and ripe for disruption with artificial intelligence because its image comes in, text comes out. You don't need that much about the rest of the world and constantly evolving knowledge to make some of these calls. You need maybe the electronic medical records, but you can get very efficient, and as you use the system, you also teach an algorithm. And those are things that are going on right now that I think will change radiology for sure, and I think a lot of the rest of medicine. And so, all right, with that, I think what the future of artificial intelligence holds for us is really that we can enhance our human intelligence. We can focus on the kinds of things that make us unique as humans, and eventually focus more and more on creative tasks. And what I love about artificial intelligence as a researcher is that on the one hand, we can solve some very concrete problems with this in radiology, in understanding human language, in machine translation, in robotics, and self-driving cars, and all these things. But at the same time, as we push the skilled level of algorithms, we learn a little bit about what makes us more unique as humans and what the definition of intelligence, what it really entails. And maybe given the last couple of days or the last week, I think it's also important to understand some of the difficulties. AI can only be as good as the data that we feed it to train. And if that data is biased or has certain problems, then the AI algorithms will have the same kind of bias. And so we need unbiased or diverse kinds of inputs to train algorithms and teach them the kinds of skills we want. We want them to, in the end, we're not really there yet, we don't have to worry about ethics right now, but as we use more and more algorithms for things like credit fraud and scoring of how much credit you should be getting and loan applications and things like that, we need to carefully think about having the right kinds of data sets. And that often starts also with having the right kinds of people work on that. And me and a lot of my friends in artificial intelligence research are immigrants. And the United States is a really great place for people who want to focus on AI. Universities like Stanford and MIT and Berkeley have phenomenal groups of artificial intelligence researchers coming from all over the world and wanting to work and advance this field. And I hope we can continue being an inclusive society that keeps bringing all these great people to the United States. All right. Thank you.